Good evening, everyone.
Good evening, sir.
Good evening, sir.
Yes, good evening. So we'll wait for a few more minutes, then we'll start the session. Okay.
Hello.
Hello, sir.
Yes, hello.
Hello, Farad.
Yes.
Yeah, hi.
Yes.
Sir, I just have a question. What are the kind of questions that is to be going to be asked from this part on for quiz one? Will it be
Quiz.
like
Quiz two.
yeah. Okay, fine. Yeah, quiz two. Yeah.
Okay. So the type of questions there are in the graded assignments, there are in the practice assignments and the activity questions.
Yes.
You can expect, or the mocks as well. You can expect questions similar to those.
Okay.
Mm.
Okay. Yeah. Thank you.
Yeah.
Hi, Farad, I had a question.
Okay.
Yeah, so in the EQM part of week 5 and 6, there's this option, events will
EMQ.
occur EMQ, sorry.
Hmm.
Events will occur simultaneously or they won't. I'm quite unsure about what it actually means. How do I, go about thinking?
Okay, we'll discuss that in a while as well. Okay.
Sure. Thank you.
Yeah. Okay, Raj Kishore will take the session now. Start.
Good evening, everyone. So I would request you to log in through JoinPD so that we can have an interactive session. I think you can all see the code, right?
Yeah.
Okay.
Sir, I can't see them. Where is the code, sir?
Yeah, just pin the page like QLN WGX. That's a code. You can just pin the page.
Hi, I have a question regarding one of the assignment question. Will it be possible now to take that question, or did you have to wait for some time?
I would request you to wait till the end of the session. So if we'll have time, we'll definitely take those questions.
Okay.
Okay, so I think 10 more students are still pending to join in the session. I request all to join in so that it would be quite interactive. We would be able to, and I request you, none of you to please don't paste the answers, or even if discuss the answers in chat unless we discuss it over here. Don't write whatever answers you want to write, you just write it in that JoinPD only. Okay, so we'll start the session. So just take your notebook and pen. So for each question, we'll be giving you 5 to 10 minutes, depending on the type of question, and we'll ask you to, in that time period, please, whatever option you feel is the right one, please put it in joinpd.com. Okay, you'll get someone who is joining it for the first time. For each question, something like this, you would get the options, and you have to choose one of those. Or sometimes there can be a response box also, in which you have to type out your responses. Okay, so this will be the first question. It's kind of prelude to the question one. And I think many of you would be facing issues with the EMQ questions. So this kind of question should help you to solve those questions also. So we'll wait for the responses for 5 minutes.
Excuse me, sir. Actually, this screen is not coming in joinpd.com. Is it just for me or?
Okay, just can you see the code in the top corner, QLNWGX?
Yeah, I
Just
actually
log
signed
into
in.
joinpd.com.
Yeah, I
Just,
logged
just
in.
type this code. It will
But
ask you to type the code.
yeah, I
Did you
typed
type?
the code. I can only see the screen statistics for data science, solve with instructor.
Or you can just
That's
refresh
correct.
the page. That happens sometimes. So you can just refresh the page.
Yeah, I think it's because of network. You may be lagging behind. Just
Okay,
refresh
sir,
it.
it came. It came. Okay, sir, thank you.
Are you all done with the question? Shall we move to the solution part?
Yes, sir.
Okay, just give me a second. Let's see the responses. It's 1468752467 1457 Okay, so there are many who have gone with 1457. There's some confusion with option 6, 3, variety of responses. Okay, so
Sir, I just want to say something that I didn't get that first 4 options.
okay, we'll discuss each option. Okay, not an
Oh.
issue. So what does the experiment says? That there are five numbers, 0, 2, 4, 5, and 9. From this, we have to form 4-digit numbers, right? And the repetition of digit is not allowed. So this kind of questions we are asking for. What are the steps you will be following to get to the ultimate final result? So if you go to the first option, that events will occur simultaneously. Now, when you are talking about forming a 4-digit number, so what do? You will select number from out of these 5 numbers, right? 0, 2, 4, 5, and 9. But you have to select the number simultaneously. It's not that you select the first number and then the second number depends on selection of your first number. It's not like that. We are ultimately forming a 4-digit number. So the choosing of each number, it's happening simultaneously. So the first option would be correct. So if the first option is correct, then by default second option isn't right one, right? Now comes the with replacement part. Now, will it be a with replacement or without replacement? Thing is, if you go with the first option, that is okay, just give me a second, I'll share the next slide, it would be easier. So see, if you're going with as I said, the first option is correct. Now if you go to the fourth option, the fourth option is without replacement, and I think 1457 many of you have responded, right? So other one is order matters and the other one is permutation is used. So we'll discuss why combination is not the right answer. First, it's because you know this, we are forming 4-digit numbers, right? So if you form a number over here, order matters, because a number 20, if you say 2045, if you're forming a number 2045 and another number 2405, so they're obviously they're different numbers. So actually it matters that in second position you are choosing which number, in third position you are choosing which number, and in fourth position which you are choosing which number, because accordingly the number would change. So that way the order matters, as well as we are talking about permutation, we are not talking about combination. When
So,
uh,
excuse me,
yeah.
sir.
Mhm.
If repetition is allowed, then combination is used.
No, over here permutation is used or combination is used. You will decide it on the fact that either I am considering arrangement among the numbers or I am not considering arrangement among the numbers. For example, if I would have said you that I have to just select 3 numbers,
Okay, so
then it could have been combination. But over here I am framing numbers, right? 4-digit numbers. Now a number value will change depending on what value, what digit is there in that ones position, tens position, or hundreds position, or thousand position, right?
yeah, sir,
So
got it.
so I'm considering the arrangement of the number digits. So that's why we have to go for permutation, and accordingly
Thank
order is
you.
also metric. And now if you're going for the fourth option is also correct without replacement, because for example we are not talking, once you have chosen one number, we are going for, we are not replacing it, right? Is this clear?
So third and fourth option, please explain one.
Sorry.
Third and fourth option, with replacement, without replacement. I didn't get the point.
Just see the solution partner, that without replacement, as repetition of digit is not allowed, as it was given in the question, right? That you are not repeating the digits. So if for example for the first position you have chosen any of the number out of this 5, right? Now you are not allowed to choose that number again for the second picking up any digit, right? Did you get it?
For the first step, we have to choose either 2, 4, 5, 9. We cannot choose 0, because then that will be not a 4-digit number.
That we are not considering now. Let's say
Okay.
anything you have chosen, any digit you have chosen from for the first position, right? It can be 2, 4, 5, 7. Just forget about 0 as of now. Okay. Let's say you have only 4 numbers, 2, 4, 5, and 9. So out of these numbers, any one you are selecting it. Let's say you have chosen 2. Now, when you are going for choosing the second number, can you choose 2 again?
No.
That's what I'm talking about. So as you can't choose, means you have already you are striking off this option of 2, right? So it automatically becomes an approach of without replacement. If like if there would have been with replacement, then it's like that again you can choose 2.
That means repetition. If repetition will be allowed, then the option will be true with replacement, right?
Exactly. It's like when you means it over here it's kind of equivalent cases. Okay, when you are talking about with replacement, it means that whatever number or whatever object you have chosen as the in the first attempt, you are again putting it back for selection, or again means you can choose it again. You can put it that way. So it means that you have again replaced it back into the I mean, suppose if you think it this way, that this digit numbers are in a bag, okay, and you have already for the first time you have taken out 2 from that bag. Now when you are going to choose the second number, you obviously don't have 2 inside that bag, right?
Yes.
So that so again, for example, if you would have considered it repetition is allowed, then we can what we can do that we can put 2 again inside the bag. So it's that again we are replacing 2 into the bag, right?
Yes.
So that's why it's kind of equivalent.
Oh, now
Sir,
got the.
can I have an example for events will not occur simultaneously?
Sir, excuse me, sir. Sir, what's the difference between order matters and order does not matter?
Okay, so order matters over here because as I said you, the numbers, if you have chosen for the 100th place, let's say 2, and then when you are choose and for the 10th place you have chosen 4. Okay, but if I'm now changing it and I'm choosing for the 100th place 4 and for the 10th place 2, then definitely I'll be getting a different number, right?
Yes, sir.
So accordingly, we are saying that order is mattering, that for which position, which number I'm choosing. Is that clear?
Okay, yes, sir.
And I think someone else was asking about events not occurring simultaneously. So for example, let's say you are for an arbitrary example I'm taking, that you have tossed a coin and you are saying that if I'm getting a head, I will toss a coin again, or if I'm getting a tail, I will roll a die. Okay, so over here my first event was tossing a coin, and my second event was depending on my first toss, either I will again toss a coin or I will roll a die. So over here my second event is depending on my first event, correct? So over here my 2 events are not occurring simultaneously.
Okay,
I'm having okay. So
sir,
is this
if zero is the not option in this problem, then order does not matter. I think.
no, still the order will matter. Like for example, just forget about 0. Let's say you have only 4 numbers. So if you have chosen for the 100th place or the 1000th place, if it's a 4-digit number, let's say for the 1000th place, first you are choosing 2, and for the 100th place you are choosing 4. Okay, so let's say you are forming a number 2, 4, 5. I think the example in the slide will help you out. Oversee for the in the first place 100 in the first option I've chosen in the 1000th place 2, and in the 100th place 4, and in the 10th place 5, and in the 1th place 9. But in the second option I'm choosing 100,000 plus 9, and in the 1000 plus 9, 100 plus 5, in the 10th place 4, and in the 1th place 2. So in which place which number I'm choosing, that matters, right? Because my number is ultimately changing.
Yes, sir.
These 2 options are without 0.
Yes, sir.
Correct?
Yes, sir.
Is this clear
Yes,
now,
sir.
all the options?
Yes, sir. Thank you, sir.
Sorry, one little explanation regarding the simultaneous thing. Because as we are choosing 4-digit number, right? So let's suppose like we'll fix like a units place with some number, then we'll go to the 10th place, right? In that case, if I want to decide what comes onto the into the 10th place, I'm fixing the first units place because repetition is not allowed, right? Then can it be simultaneous? Yeah, go ahead, sir.
Yeah, still it is simultaneous, because ultimately you are choosing all possible ways, right? It's not that you have fixed one case and you are talking about that. So arbitrarily first place can be any number, and then accordingly the second place can be any number. So you are doing it successively, right? It's not that it's just for counting. We are taking it that way, that I have chosen the first number, then I'm going for the second number, then but ultimately it's happening all together, that 4 digits I've been taking from this 5 digits. Out of 5 digits I'm choosing 4 digits, right?
Got
so it's a consecutive thing happening.
Right. Yeah. Thank you. And one more thing. Over the assignments on the portal, right? The similar format of EMQ type of assignments. Do we have to enter our answers into a notepad and upload the file in a zip format?
Yes, you have to. Yeah, you have to write down your answers, I think in a sequential order as well,
Okay.
and then just submit it as a file.
Okay. Yeah. Thank you, sir.
Okay. Okay, we'll move to the next question. That will be also a prelude to question number 2 only.
Sir, sorry, if I may ask one question. I mean, not a question, just a understanding part of it on the previous one. Okay. Though the question talks about selection of digits, it's actually the arrangements that we are talking about, right? Not actually the selections, because in the
Exactly.
in the
It's about permutation. I think the last option was that about only, right? That
Correct.
either it is permutation or combination.
Correct. Yeah, because and though the keyword selection is there, so we should not get confused with it is as a combination. It's actually the arrangement of digits, not the selection of digits.
The clue you can take from is that as you are framing numbers, so the order will matter, right? So I can't. Yeah. So it won't be just selection. I have to also arrange those digits or numbers.
Yeah. Got it, sir. Yeah. Thank you.
Yeah. So we'll move to the response part. I think almost 70-80% have responded. Okay, so these are a few extreme cases are also there. Okay. So for this question, it was simple that how many 4-digit numbers? I think many were talking about it from the last slide also. So for this, the most important thing which you have to consider is the zero part. Okay, that as we are forming 4-digit numbers, so at the 1000th place we can't have zero, right? That is the only thing which you have to be very careful about. So for this 4-digit number, if you're filling up, so what would be the in the first place, what are the possibilities we can fill it up? Other than zero, we can fill it up with other, right? That is
Yes.
you have options for 2, 4, 5 and 9. That is 4 possible ways. Now out of when you have filled up the first place, you have already chosen one number. Now as we are talking about without repetition, so we can't take that number, so we'll be again left with again 4 numbers, because let's say for the first place we have chosen 2. So now for the second place we can't choose 2, or the 100th place we can't choose 2. We'll be left out with 0, 4, 5 and 9. So again the 100th place can be selected in 4 ways. Now once you have chosen that, now for the 10th place or the 3rd place, you will be left out with 3 options, because again we are not going for repetition, and the last place can be chosen in 2 ways. Is this clear to all? So it will be ultimately 4 into 4 into 3 into 2, 96.
Yes.
Anyone any doubt with this slide?
Sir, first you are filling with 1000 place number, right?
Yes, we are starting from the 1000 place, because see, if someone can say me that I'll start from the ones place, then what happens is that you will not have the control of this zero with you, right? Because someone you won't be able to count it, because maybe in the ones place or the tens place or 100 place somebody is already filling up zero. Then it will be very difficult that to correlate that whether in my 1000 place I'm getting zero or not. So the extreme cases, always try to separate them out for at the first only, so that you will have the full control of the last places with you only. So that I know that I don't want in my 100,000 place zero, so let me start with that only, that I'll not keep zero in my 100,000 place. So how many are left out? Okay, that
Okay,
makes
sir.
my calculations easier.
Okay, sir. Thank you, sir.
Okay, so we'll move to the next slide. Okay, this is prelude 3 to that same question number 1 only. The constraints are now different. That's it. All of you know the conditions, like how to check if a number is divisible by 4 or not?
Yes, sir. Last two digits should be divisible by
Yeah,
4.
correct.
Sir, on my screen, the last question is only showing up. So, do I need to do something to move to the recent question?
Just refresh it and check it once. I think it may be to network lag only.
Okay, okay.
Anyone still trying out the question, or shall we move to the solution part?
Done, sir.
Done, sir. Okay. There are a lot of different answers. Okay.
Hello, sir.
Hmm? Yeah.
Sir, how to give response of the answer by chat menu?
No, just log into JoinPD. You can see the top right corner. You'll find a code which is QLNWGX, and then you'll be able to see all these slides, and you will also have a response text box to type your responses. Okay. Okay. So, what should be the approach for this question? As you see, as I was talking about in the earlier question also, that whenever you find a constraint, like in the earlier question, the constraint was my the 4-digit number should not start with a 0, else it would become a 3-digit number, right? So that was the first thing which we were tackling. Over here also, my constraint is divisible by 4. So that is where we'll first tackle it. Okay. So as you all know that divisible by 4, the rule is for the last 2 digits, that is ones place and the 10th place, the number should get whatever the number digits are, it should get divided by 4. So for that reason, over here, using just this 5 digits, that is 0, 2, 4, 5 and 9, what are all the possible combinations you can make that the number would become divisible by 4? Anyone?
4, 20,
Huh.
40,
Correct.
52, 92.
Correct.
The 24.
24, 24 I missed.
Correct. So now what we have to make is that we have to consider all these cases separately. As I was talking over there also, we were trying to take 0 out, and then we were trying to find out all the conditions. In the same case over here also, we'll fix each. Let's say when you are telling 0, 4, if my last 2 digits are 0, 4, then my whole number would be divisible by 4, right? So I will fix 0 and 4 in my ones and 10th place, and then I will try to arrange the other 2 places left out with the other whatever left out digits. Okay. So for example, if we move to the solution, so as you are talking about that, these are the possible combinations: 0, 4, 2, 0, 2, 4, 4, 0, 5, 2, and 9, 2. If I have my ones place and 10th place as this, then only my whole number would be divisible by 4. So now we will find out all the cases. So for the case 1, I'm taking, let the number ends with 0, 4. So if my number ends with 0, 4, then the first 2 places I can fill up with what all possible cases. I'll be left out with 2, 5 and 9, right? Because 0 and 4 I've already fixed in the tens and ones place. So if I'm the first place, that is the 1000th place, I can select any of these 3. It can be either 2 or 5 or 9, so that I can fill it up in 3 possible ways. Once I'm done with that, then the second place I'll be left with 2 more options, because as repetition is not allowed, so I'll be left out with two more options. So ultimately, for case 1, how many possible ways we can make the numbers? It is 3 to 6 ways, right? Is this clear to all?
Yes, sir.
So you can also write it in 3p2 ways also. Means from, if you're using week 6 concepts, that is permutation, that you have three possible numbers to select, and out of that you are choosing 2 numbers and arranging them. So it becomes 3p2 ways, right? Now similarly, if you're going for 20 and 40, the number of ways to fill in the remaining 2 places will be again 3p2, right? Now there is one more thing to consider over here, that when I've already fixed in the ones and tens place this 0, I've already taken, so I won't have that headache of considering it in the ones, tens, in the 100 place or the 1000 place, because already my 0 is fixed in the first half, that is ones or the 10th place. That is for when I'm taking 0, 4, 2, 0 and 4, 0. So arbitrarily I was able to take 3p2 ways, because I can choose any number in the 100th place and the 1000th place out of 259. There was no restrictions. My only restrictions were, if I should be careful that my 0 should not go in the 1000th place, right? But if I'm not fixing up in the first 2 places 0, that was the other 2 cases. If you see, these were the all possible cases, right? So for 0, 4, 2, 0 and 4, 0, I don't need to take that extra cushioning of that in my 1000 place, will there be 0 or not? But let's say if I'm fixing in my ones place and tens place 52 and 92. Now in the ones and tens place, I don't have 0. So I have to be very careful when I'm choosing it for the hundreds place and the 1000 place, because in those places 0 can occur. So for those three cases, we'll tackle it in a other way around. That is, if the number ends with 24, now I'll be left out with three options, 0, 5 and 9. But in my in the 1000 place, I can't choose 0. So how many options I'll be left out with? Only two options, right? And once you choose in the 1000 place out of this 5 and 9, any of the number, then again for the 100 place, you will be left out with only two options. Let's say if you have chosen in the 1000 place 5, then for the 100 place, you will be left out with 0 and 9 as a possible numbers. And similarly, if you have chosen 9 in the 1000 place, then you will be left out with only 0 and 5 for the 100th place. So again, it will be 2 into 2, that is 4 possible ways. And similarly, you have to do it for 52 and 92. And once you get all the possible cases, that is 6 possible cases, you just need to sum them up. That is for the first three cases where my 0 was already taken care in the 100 and 1000 places, I've done it in 3p2 plus 3p2 plus 3p2 ways. And for the other cases where I had to take care of the 0 in my 1000 place, I've done it in 2 into 2 possible ways, 4 ways, and similarly for the other three cases. And it would come out to be 30. Is the solution clear to all?
Yes.
Sir, could you please just say what criteria you use to check the numbers which are divisible by 4?
See, for a number to be divisible by 4, the whatever number you are getting in the 1000 place and the 100 ones place and the 10th place, let's say for example a number we have from let me go to the other side. Over here, this 04 has to be there in your ones and the 10th place. Okay, so let's say my number was, I'm making a number 2504. Okay, if my number is 2504, then I'm having in my ones place 4 and in the 10th place 0. So this is the number I'm getting in the from the last two part, right? 04.
Yeah.
So this number is divisible by 4. This number is divisible by 4. So the whole number will also be divisible by 4.
Yes,
Let's
sir.
say I'm forming another number 4520. Sorry.
Yes, so please continue.
So let's say you're choosing another number 4520. So the last part is 20, right? So it itself is divisible by 4, correct? So the whole number will be divisible by 4 again.
Okay. So the last two numbers must be divisible by 2 together or single.
No, the last two numbers together should be divisible by 4. Then only the whole number would be divisible by 4.
Okay. So sir, just to clarify a bit, if suppose we had 8 also a part of this series, so if we had 0, 8, so even that would be divisible by 4, right? In the units and tens place.
Yeah. So if your number would have been 5908, then that should also be divisible by 4.
Okay, got it. Thank you, sir.
Then read the first line also. By the divisibility, for a number to be divisible by 4, the last two digits of the number should be divisible by 4. That's the rule. Okay.
I thought we have to add both of them. That's why I got some wrong answers. Now it's clear. Yeah.
Okay. So this was all the preludes was to this question, final question. And this now the constraint has changed, that how many possible numbers can be found such that it is not divisible by 4. Can you all just mute yourself? Whenever if you have any doubt, you can just unmute and ask it. Harshit, don't type the answers in the chat box, okay? Once everybody is done with the answers, then you can unmute yourself and discuss it. That's okay.
Okay.
Hmm. Are you done with solving the question, or you want more time? Anybody is still solving it?
Done, sir.
So just a minute.
Okay. All right. Okay, we'll check the responses. Again, there are a variety of responses. Okay, so what should be the approach? Anybody, any idea? Like, how should we approach this kind of questions?
Sir, is simply total number formed is 96, and number which is divisible by 4, that is 30. So I think 96 minus 30 is equals to 36.
I also
Okay.
did by that, but I don't know right or wrong.
So see, whenever again I was talking about, see, check the constraints, whatever it's there. So for example, if you would have gone through that, how many numbers are not divisible by 4? Directly, if you would have tried to find out the numbers that are not divisible by 4, then there could have been much more possible ways, right? So it's easier to do it in the other way around, but I think all of you have followed that only, that how many all possible 4-digit numbers that can be formed, and that out of these 5 digits, right? Try to find that, and then try to find the number of possible ways you can find frame numbers which are divisible by 4, and then subtract it, and then you will be left out with numbers that are not divisible by 4.
Yes.
Yeah. So the number of possible 4-digit numbers is 96. Because again, how are you getting 96? If just to recap it, for the first possible case, we won't be considering 0. So for the first position, so we'll be left with 4 possible ways. And for the second position also will be left with 4 possible ways. And for the third, it will be 3 possible ways. And for the last position, that is the 1st place, it will be 2 possible ways. In that way, we'll be getting 96. And then the number of possible ways, we can frame 4-digit numbers that are divisible by 4. We have done it in the last question. It came out to be 30. So we'll just subtract it. We'll be left with 66. So those are the numbers that are not divisible by 4-digit numbers. So when you find this kind of questions where you find an enormous number of possibilities, try to find take this approach of complementary. Okay, it's kind of that from the whole you will subtract the complementary. The complementary is what? If we were asked about not divisible by 4, the complementary event will be divisible by 4, right? So you can subtract that, then you will get that not divisible by 4 case.
Yes, sir. Got it.
Anyone, any doubt? Yeah.
So there is any another approach to do this question?
The other approach can be that you will try to find out all possible ways where it is not divisible by 4. So you have to go for all the possible cases where the first means the 10th place and the 1st place, those are, you have to fix the numbers in such a way that they are not divisible by 4, right? All possible ways. Let's say for example, what were the digits? Let's say 0, 2, 4, 5 and 9, right? So you will know that I know that if I'll have 0, 4 in my tens and ones place, then that number would be divisible by 4. So I'll not take those numbers. I will take all possible other cases like 0, 2. I know that 0, 2 will not be divisible by 4. If I have my last two numbers as 0, 2, then that number won't be divisible by 4. Then again I will go for 0, 5. That will not be divisible by 4. Then again I will go for 2, 5. That will not be divisible by 4. So that way the number of possible cases would increase much more. Okay.
So which one is less time consuming?
This would be least time consuming.
Sir, I did an approach. I just want to clarify what I mean. I am getting a different answer. Just want to see like if I missed out something. Okay. See, the approach which I did is like the number of 2 digits. I mean the last units and tens places. The number of 2 such digits that can be formed with 5 number is 20.
Number of last 2 digits.
Yeah, that can be formed is 5 into 4, which will be 20, right? Because we have 5 numbers, right? So it will be 5 into 4, which is 20. Okay. Earlier we found out that there are 6 numbers which are divisible by 4, right? So I subtracted that. So remaining will be 20 minus 6 will be 14.
Okay.
Okay. So out of that 14, I saw that how many digits will contain 0 in it. Okay, because there is 0 with 4 digits, right? So we could possibly get eight permutations.
Okay. You are talking still about only the last 2 digits, right?
Yeah, last 2 digits, correct. Yeah. So last 2 digits, the number of numbers which could contain 0 is 8 numbers. Okay. Out of that 8, 3 was already appearing in our divisible by 4. So remaining is 5. Okay, so out of that remaining 14 which we had, 14 minus 5, which is 9. So 9 numbers which doesn't contain 0 in the last 2 digits, 5 numbers which contain 0 in it. So if it contains 0, then my my previous things would be 3 into 2, which is 6, right? So 6 into 5 will be 30.
No, but when you are considering as from the initial part, these all events are occurring consecutively, simultaneously, right?
Correct.
So if you are separating out that way, then you are not, you may not follow this constraint of repetition, because ultimately you are finding out the last 2 digits separately, all the possible ways, and then you are trying to add it up with this part. Means you are trying to club them with the first 2 parts arrangements. But then there can be cases where you have taken some same digits which would be in the last 2 places that can also occur in in the first 2 places, right? In the hundreds place and the thousand place again.
Okay.
So that way you have to consider at a go all the 4 places, 4 digits. What you are trying to do, you are trying to first separate out the last 2 places, and then you are trying to find out all the possible ways in the first 2 places, correct?
Correct.
But in that case, as there is, you are not keeping an interlink between all the 4 cases, means all the 4 places, then you may not follow that repetition constraint. But when I'm already fixing the difference between what you are saying and in what procedure we are following, let's say I'm already fixed. For example, if I'm finding out all the numbers that are not divisible by 4, then I can fix 2 and 5 in my first ones and tens place, right?
Okay.
So then I'm already fixing it. So I'm sure now that I'll not pick up 2 and 5 for the 100 and 1000 place. So I'll be left with either 4 and 9 for the 1000 place, and rest 0 and the other number for the 100 place. That way I'm obeying the repetition constraint also.
Okay.
But if you're doing it separately, then there may be cases where the digits may get repeated, because you are not keeping an interlink, because over here you have just taken care of that my 0 how many times occur in the first 2 cases, right? I mean in the 1s and the 10th place. But what about the other digits? If they are occurring, then how will you interlink it with the first 2 places? Means, for example, there can be a case where in the 1s place you have also got 2, and in the 1000 place also you have got 2.
Okay.
Okay, so we'll move to the second.
Yeah.
Okay, so this is the prelude to the question number 2. Again, it's kind of same pattern of EMQ. So I hope the first EMQ that we have solved, it will give a fair bit of idea that how to go about this question. So it should not take much. Sorry? Okay, so we'll move to the response part. 1468. Okay, then again there are variety of responses. Okay, many have gone with 1468 only. 58. There's some confusion with option 6 and 5. Okay. So, okay, so there is confusion that either order will matter and order doesn't matter. So what does this experiment talk about? That we are choosing a team for World Cup and we have to choose 4 players out of 10 players, right? Now the squad is to be selected such that 2 players, say X and Y, will either be selected together or both are not selected. From the given list of options, select the steps applicable for selection of players. Okay. So anybody any doubt with option 1, why it would be correct one? Why it
Yeah, I have a doubt, sir. When you say a player X and Y are to be selected together, or both are not selected, right? So we are saying there is a dependency. Like if X is selected, Y has to be selected. If X is not selected, then Y don't have to be selected. Y should not be selected.
No. See, we are taking dependency little in a different track. Over here, am I doing the event simultaneously or not? For example, I'll not select one player and then sit for selecting other player, right? I'm altogether, I'm selecting 4 players at a time, correct? Either I may choose X and Y together or not, that's a different thing. But ultimately, out of 10, I'll select 4 at a time, right?
Yeah. Okay.
Sir, I have a doubt in that. How we select player by player, right? We don't in real life we don't select like 4 at a time because we don't know who's at 4. We need to go player by player, so it's not a simultaneous event, right?
No. Let's say if you are the coach, you will make your mindset that I will take this 4 players, right?
Yes, sir.
And
Even then, I need to go through one by one, right? I won't go like on a straight these 4 like. It also it's an ambiguous question. It can be that you go one by one, or it can
no.
be that you depending
If I
on this,
No. If I'm
depending on the
framing a
coach.
team, I will declare that these are my players whom I've selected, right? Whenever, for example, in cricket, if I'm seeing, whenever I'm for taking out that these 11 players will be in my playing 11, it doesn't happen that today on Monday I have declared that this is my first player, on Tuesday I have declared this is my second player. At a whole, I am declaring that these are my 11 players who will be playing, correct?
Yes, sir.
So
Even in that stage, you'll say have 70 players in front of you, and you need to pick from them, right? Doesn't happen like you know the 11 from all the 70, right? That's
No, that is different case that I know them or I don't know them. Over here, what matters to me is that is this events happening simultaneously or not? So I can, when I'm framing a group, I'll be taking all the 4 players at a time, right? It's not that it won't happen that my first player will be there, then second day I will choose another player, or third day I'll choose another player. All
yes,
that
sir. That's
for
right.
framing the
But
team,
it'll
I
take
will have
1
to have
second
4
to
players.
choose one. What will take at
No,
least
no,
1 second to choose.
no, that way we are not. It's not a physical thing where we are saying that will there be timing difference or not. But in a broader sense, it's trying to say that to make a team, I need 4 players and I have to choose 4 players. So all the things have to, all the means choosing of 4 players has to happen simultaneously. Then only I can have a team of 4 players, right? Else I'll not have a
Okay.
team of 4 players only. I'll have either if I'm choosing one by one, then I'll have a team of 1 first, then 2, then team of 3 in that way, right? But what in a broader way we are trying to say is that to make a team, I'll need 4 players. So I have to choose altogether 4 players only.
Okay, in that sense. Okay, okay.
Okay,
Yeah,
now
so got it, sir. Yeah, got it. So then, can you just give one example where it would, it will not occur simultaneously, so I can distinguish between when I have to say it is simultaneous or not?
I think over till the end there will be questions where you will have simultaneously.
Okay, fine. Thank you.
Sir, in this question, we are talking about 2 options, right? Where 2 players are selected together or both are not selected. So, which means like in this scenario, these events will not occur simultaneously, right? Either 2 will be selected or 2 will not be selected. So, both are 2 different scenarios, isn't it? I understand that 4 players will be selected together. Okay. But from these 2 players' perspective, if I consider that scenario where
No, that is a half perspective we are talking about, right? We are talking about the full perspective of choosing 4 players. In that we have a sub constant that either when I'm choosing that 4 players, my X and Y will be there or my X and Y won't be there.
Okay, so when such questions are asked, this talks about the full questions. So if it is a sub for the sub question, if there is a question to ask events selected, I mean events happening simultaneously or not, so there will be a specific for that scenario, is it?
Yes, I'm talking about the event of choosing 4 players.
Okay, okay, sir. Yeah.
Okay, now when you're talking about replacement or without replacement, now again it's a case of without replacement, right? For example, let's say if you're going if I've chosen already let's say XYZ, okay, let's say I've chosen Ram in my team. Once I've chosen Ram in my team, then again I can't choose Ram in my team, like Ram is already in my team, correct?
Yes, sir.
So for next selection I won't have Ram as an option to be selected, so that way it is without replacement. And now order matters or order doesn't matter. Again, for example, I choose first Ram and then Sam, or if I choose first Sam and then Ram, it doesn't matter because ultimately in my team both are there, right?
Yes, sir.
Yes, sir. Yes, sir.
So that way order doesn't matter. And accordingly, permutation is also not used. It will be combination that will be used, because again, it doesn't matter to me in my team the arrangement among the players, right? Ultimately the all 4 are in my team, that's it.
But most of the time, if order does not matter, then combination is used.
Most of the not time is the wrong thing. Every time whenever order doesn't matter, you will use combination only.
And if order matters, then permutation is used.
Yes, if order matters, then we are talking about permutation. If order doesn't matter, we are talking about combination. Combination considers about selection only. Over here, like we are selecting 4 players, right? But if I would have said, yeah.
Yeah. And now I understood that when with replacement and without replacement. Okay. But when this second option will be valid, events will not occur simultaneously.
Yeah, I think I'll check the slides. If there's no more question of events not occurring simultaneously, then I'll give you an option. Okay, example.
Okay.
Hello,
Others
sir.
all, yeah.
Yeah, I have a question. We have to choose 4 players from a group of 10 players. And if X and Y cannot come together, or they both cannot be a part of team together, how many possible ways are there to choose such a team?
Yeah, we do have a question. Just wait in the further few means slides.
Okay,
You'll have
so we have a similar question.
yeah. In just a period, you'll solve all these pattern questions. Yeah.
Excuse me, sir. Sir, I am unable to understand the with replacement and without replacement.
See, as I'm in the broader perspective, you have to see that when I'm talking about with replacement, I'm saying that for the next, when I'm selecting, do I have that option of selection or not? If I'll say with replacement, then again, once means in my first trial, if I've selected one thing, then in my second trial also, I'll have that option to select it again. Then I'll talk about with replacement. But when it's without replacement, once I've selected something in the second trial, I'll not have that option to select it again. Okay, so for example, over here, if I have selected Ram in my team already, then now second time I can't select again Ram, right?
Second
So
time, yes,
it's all about repetition or not repeated.
Exactly. If you're talking with case of digits, then it becomes that repetition or without repetition case.
Oh, means if I am forming another team, let's say I have formed one team, Ram, Shyam, Sundar, and
No,
Shivam.
we are talking just about one team.
Okay. That means
that,
if I form another team, then I can select Ram, na?
No, but over here we are talking about one team, right? In one team, how many
One
players?
team. Okay, sir.
So that means that in this question there is no use of the other information, right? Other piece of information, the X and Y.
No, for this question will not be using it, but for the next questions we'll be using it. Okay, it's a full question. We have divided into subparts and we are trying to frame it. Like for this question, this slide was mainly to help you to solve the EMQ parts, right?
Okay, yeah, got it, sir.
Yes.
Okay, I'll move to the next one. Yeah, this is what you were talking on. In how many ways can the squad be selected if both X and Y are included in the squad? Somebody was asking about it. So this is that question.
I was asking about how many ways if they are not included. I mean, if either X included or Y included. That.
Sorry, can you come back again? I couldn't hear you. Hello.
How many ways can you select a team of 4 from 10 players if X is selected or Y is selected?
Okay, so you are asking
if X comes, then Y is not there, and if Y comes, then X is not there.
No, but over here the condition is different, right? That my both X and Y has to be in the team.
Or yeah, my question is the other way. That's what. Okay.
Yeah. So no, if you are saying X, if you have a condition that either if X comes, Y will not come, and if Y comes, X will not come, right?
Yes, sir.
So in that case, it's nothing. You will just fix. You will divide it into two cases. In one case, you will fix X. Then for the other options, you will not take consider Y directly. And in for the other case, you will fix Y. And then for the other cases, you will not take X into your selection criteria.
Okay. Can you just show how to do the calculations?
Just solve this one, then we'll talk about that. Okay.
Okay. Yeah.
Eight choose.
Can you all please just mute yourself? Okay, so when we're talking about in how many ways can the squad be selected if both X and Y are included in the squad. So again, we are having the constraint that will be including both X and Y, right? So again, as I was talking about that when you get a constraint, try to fix that only. So we'll divide it into cases that in one case where I will have both X and Y in my team, and in the second case where I'll not have both X and Y in my team. So now, if you're talking about this, 2 places out of 4 are already filled by X and Y, right? Because it is giving me what was the criteria? The criteria was that my X and Y are already in the team. So now I have to see that how many possible ways I can arrange them. So out of 4 players, I've already taken X and Y as they're fixed. Now for the rest 2 places, how many possible ways are there? It will be
C2.
sorry.
8C2.
8C2.
8C2 bits.
Right, 8C2 is okay. Over here also it's 10 minus 2 and C, and then it is out of 4, 2 have already gone, so 4 minus 2. So it's 8C2. Okay. Anybody any doubt till now?
Sir, I didn't get it.
See, the constraint that was given to us is that my X and Y has to be in the team. So already I have taken them in my team. Let's say somebody comes and tells you that you have to choose 4 players. Now somebody comes and tell you that my X and Y has to be in the team. Rest whatever you want to do. So you have already 2 places are already filled for X and Y, right?
Okay.
So how many places are left? Only
8.
2 places left. Sorry, 2 places are no, 2 places are left to be filled. You have 8 players to choose from.
Yes.
So that
From 8, you have to choose 2 players. Okay.
so that's why it becomes 8C2. Okay. Is this clear?
Yes.
Sir, if we have to do in the same way like we were doing the previous question, then the X and Y would occupy 2 spaces. So what is left over is next 2 places. So for next 2 places, we fill one with 7, another one with 8. Then we multiply 7 by 8, which is going to be 56, right?
Correct. But over there, when you are doing, when you have already fixed 2 places and you are going for the last 2 places with 8 possible ways into 7 possible ways, right? 56. Over there, you are considering the arrangement among those 2 players also. Means whatever you will be selecting, either in the first place you have taken, let's say, if you are selecting Ram and Sam, so then in the first place Ram and in the second place Sham, or in the first means order, you are considering the order also. Okay. But as I was talking about that in this case, order doesn't matter. So I'll not be considering the arrangement among those 2 players. So again, I have to divide 56 by 2 factorial. I'm taking out the arrangement among those 2 objects which I have selected.
Got it. Okay. Yeah.
So first 2 already have been chosen. So we will not talk about that. We will talk the rest 2 players, right?
Yeah. What you have fixed it, don't talk about it.
Okay. Got it.
So do you go to the previous slide, Pramod? Okay. Yes, of course.
Okay, so I think what we are talking about, no, that when the events will not occur, others you can do it, this question. Those who are not understanding about the events not occurring simultaneously, what can be the cases? Let's say, I don't know, the more you will be clearer about it when you will learn probability for in the next week. But what we talk about it, it is called mutually exclusive events. Okay, so what happens in that case, that what kind of events can you call as mutually exclusive? When means both cannot occur simultaneously, means cannot happen. Means for example, when you are tossing a coin, either you will have head or you will have tail. Can there be a case that you can have both head and tail?
No.
So those kind of events are called mutually exclusive. Means if one happens, the other cannot happen anyway. Okay, but over here, let's say when you are choosing the number, when you are choosing the players, for each time when you are choosing it, it is that any possible thing can happen, right? That cannot happen. Means if I can have 2 also, I can have 3 also, I can have 4 also, all are possible. Correct. It's not that if 2 is there, then 4 cannot be there.
Can be there.
So that way it's the yeah, and you'll get more clear idea about this when you will learn about mutually exclusive events. Okay, next week from probability. So over here my constraint is that X has not been included in the squad, right? So try to, whenever the constraint is there, try to attack that. That would help you in solving out the problem. We'll go to the responses. Okay, many have given it around 70. Okay.
My
So
response is not showing there. Why?
sorry,
It is not showing there.
what is not showing?
My answer, that the answer that I gave is not showing in your response sheet.
What was your response?
My answer was 126.
126. Okay, so basically it will be around somewhere this. Okay, because this is your 126, right? Can you see it?
Yes, sir. Yes, sir. I can see.
This scale is a bigger one, right? So
Yeah,
that's why.
that's right. Yeah, I understood. Yes.
Okay, so what should be the approach to solve this? The earlier constraint was that x and y has to be always together, right? So if I'm talking about that x is not included in the squared, then obviously my y will also be not in the squared, correct?
Yes, sir.
Yes.
So now to choose 4 players, how many options do we have?
8C4.
6. No.
10C4 is equal to 210.
It will be 8C4, right?
Yeah.
Oh,
Anyone?
8C. Okay. Okay.
Any doubt?
8C4.
Yeah, so the correct answer will be 70. 8 because as I have excluded x, so y will automatically be excluded because ultimately they both want to be together only. They don't want to be separately there in the team. So automatically if I'm keeping out x, then y said that I will also not be in the team. So I have only 8 possible ways, and as I had to fill up 4 places, so it becomes I have to choose 4 players out of this 8. So it becomes 8C4. Okay. And we are doing 8 means 8C4 and not 8P4 because again order doesn't matter and we are not talking about arrangement among those 4 players.
Order is not matter.
Yeah, so it's just selection.
Why 4? Because 8, if you excluded x, y is also excluded. Okay, among them we have to choose 4. Okay.
Yes. 8 is the number of available choices. 4 is the how many I want to choose. Okay.
Okay.
So the total number is 70 plus 28.
Sorry, 70 plus 28?
Yeah.
Sorry, I didn't get it.
Okay, so this is the final question that the last 2 questions are breakdown of those this question only. So for this, in how many ways can the squad be selected? I think someone was talking about this answer, right? Someone said about, right, the addition thing.
Yes. 98 ways.
So this is nothing.
70 plus 28.
All that last 2 cases you have to go through that. Okay, 70 plus 28, that part only. Okay, na? Anybody any doubt?
No, sir.
Okay, so we'll just move to the fit. This is just that solution only. So from I request everyone to just mute yourself. Okay, so from this, Farad will be taking over, and you can just fill this part, whatever you feel about the EMQs that have been given till now in the assignments. Is it helping you or not? Would love to know your responses, whatever you feel about the EMQs. And now Farad will be taking this.
The EMQs are a little ambiguous. It depends from person to person's perspective. So
Yeah, hello
somewhere
everyone.
Hello.
So now I'll be taking the session from this point ahead. Okay. So you guys, like, if you have any feedback regarding the EMQs, if you're facing any difficulties, or if you feel like it's a better way to test your understanding of concepts, you can just share your feedback with us.
The options are not clear all the time. Which options? The confusion.
There is a little confusion. Okay.
Yeah.
So like, does it help you test your understanding?
But now after this
No.
session, maybe I'm able to understand. But before that, I'm not able to get it.
Basically, there are a few options for that we will discuss like explicitly in probability in the upcoming week. So those options are a little bit confusing to some of us, right?
Yes.
Sir, are
So
you
don't
planning
worry.
Are you
Sorry.
planning to add these EMQs for the next upcoming quizzes?
In the quizzes, I don't think there are EMQs. These are just these graded assignments, and I think these are bonus.
Okay, because right now I'm finding them little, what shall I say,
difficult.
Not much practice with them, and so
yeah, that's a
some mistakes.
feedback. That's the feedback from your side. Oh, it's missing.
But the EMQ tests are very useful, sir, for approaching the question.
Exactly. Basically, that is the purpose of these in EMQs.
So that can be
So
for people thinking in line with the IITM. Some people might have different perspectives. Like, for example, there are different ways of looking at a question when it has a broad perspective, broad way of looking at it. So sometimes you might think differently with comparison to what the question setter is thinking. So then it will be just for the persons who think like you, for them to answer. Then it'll become wrong, right?
Basically, that is
Whereas
the case
in the
every question. Like,
no,
if
but
you don't think
whereas
the
in the
way.
MCQs, there's a specific way. Here, there's a broad way, broad answer type for people.
Yes, exactly. So, just a moment. You're able to see my screen, right?
No,
Yes.
not yet.
Just a moment. Is it visible now?
Yes, sir. Nice TP.
Awesome. It's not visible.
Okay, now it's not visible.
It's visible, right?
Yes.
Okay, so we'll proceed to the next question now. So take your time to solve this question, okay?
Three distinct awards. Okay. How do you Flower, okay.
Sir, is that EMQ considered for grading?
I don't have any ideas about that, but I think they are just there for the bonus marks. And I think mostly they are not graded. They're just there for the bonus marks.
So fifth week EMQs are extended till 15th, right?
Yeah, there were some doubts from a few students, because of which some doubts and something to do with the registration and all that. So because of that, the deadline has been extended now, I think.
So this bonus is for this quiz 2 or the end term exam?
No, basically when you in a subject, when you get these bonus marks at the end of like grading, when your grade point, your score, total score is like collected or it's there, then the total bonus marks that you get, they will be added to that total final score that you score throughout the course from quiz 1 to end term. Then it will be added.
One quick question regarding the quiz 2 content, right? Do we do we have to prepare from the quiz 1 to quiz 8?
Yes.
Or is it like a quiz 4 to quiz 8?
No. There will be questions from week 1 to week 4 as well there.
Okay.
So now the thing will be that more weightage will be given to the questions from week 5 to week 8.
Okay.
That makes sense.
Even for the same criteria for end term, right? Like a from
Yeah,
week
end term also, like there it might be different for different subjects. So basically, like if you see, it will be the same. Like more for end term, there will be questions from week 1 to week 12. There might be more weightage of the questions from the last weeks or the more important weeks.
Okay, got you. Thank you.
Yeah. So let's see. I've got 21 responses. Let's see. 1486, 1468, 1468, 1468, 14. Okay. So I've got a variety of solutions. So shall we proceed ahead? Or is anyone still solving it? Okay, we'll move to the solution now.
Yes.
So the options 1, 4, 5, and 7 are correct in this. Okay, so the distribution of awards among the students will be simultaneous. Like Raj Kishore took quite some time to explain this concept of simultaneous and not simultaneous, right? It's not the case that if you give one award to the one student, you cannot give to the other student at the same time. Just like flipping of a coin, you cannot get heads and tails at the same time, right? But you can divide the awards to different students at the same time. So the distribution is going to be simultaneous, and it will be without replacement, because it is clearly mentioned in the question that one award can be given to only one student, right? You cannot give one award to the student, take it back and give it to the other as well, right? For one student, we'll have one award. So because of that, there is no replacement. We are not replacing the award back and giving it to another student. Okay. So that rule, we are done with the first 4 options, and following this logic, option 1 and 4 will be correct. They will occur simultaneously and there will be no replacement. Okay. Now coming to the 5th and 6th option, that is basically about order. In this question, order will matter. Why? Because if you take 2 students and if you are saying I will give to one chocolate and the other toy. So it will depend on you. Order matters. You can either give one student toy and the other chocolate, or the other chocolate and the other one the toy. So order here matters, right? And whenever order matters, we know the what we are dealing with is permutations, right? Because we have to make arrangements. Okay, so because of that, we will say that order matters, and hence option 5 is correct. So when option 5 is correct, we are dealing with permutations. So which makes option 7 correct, and because of that, option 8 is incorrect, right?
Yes.
So
Okay.
just
Any?
a question.
Yeah.
Here the order is for the student, right? It's not for award. So if we give the first student, we give the award to the first student first, and then come to the second student. That is up to the order, or is it about giving a chocolate first or a toy first?
Okay, I'll say like this. If you have like in your mind, you have decided I will give the first student, I will give chocolate, right?
Yeah.
Okay, and the second one I will give a toy, right? So now in this, for example, there are two students, X and Y.
Yeah.
So X is the first student you give chocolate to, right?
Okay.
But in this case, it is clearly order matters, because if you choose X as the first student, you will give him the chocolate, right? But if you choose Y as the first student, you will give him chocolates. So here order is mattering, because it's not, we are not just selecting, we are then arranging, we are giving them chocolates, right? There can be different arrangements. It's not just we are choosing, we can give one chocolate, other toy, and the other something else. It's not just we are choosing, we are arranging, we are giving them different things in this case.
So it's about the things. It's not about which student we take first.
It's about what we are giving them, and what way we are giving them, because it will be different, right? The
Yeah.
way we are giving them
Yes.
gifts.
Okay, sir.
It's really confusing.
Okay, so moving on to the next question. Okay, so the same question. Now it's not AMQ. You see, take your time to answer this question.
3 distinct awards. Yes, okay. That is flower.
So could you please tell me why order matters here?
Sorry?
Why order matters here?
Oh, in this question. Because if you give toys to, like, we have two students, that is say X and Y, okay? Giving toy to student, chocolate to student A, and like toy to student B is different from giving toy to student A and giving chocolate to student B, right? Because of that, order matters. Suppose we are saying that for the first student we will give toys, and to the second student we will give chocolates. Now, suppose the first student I chose is X. So in this case, I am giving X toys, and the second one I am giving chocolates. But if I chose Y as the first student, then I will be giving Y the toys and the X the chocolates, right? So clearly,
Yes, sir.
ordering is there. It matters there, right? The order which I am giving those, and when ordering
Yes, sir.
matters, it will be permutation.
Yes, sir. Got it.
So in such questions where we have the restriction like this can go only to A. So such questions only the order matters, is it?
Sorry, I didn't catch you. Your voice was breaking a little.
Okay, is it better now?
No, it's clear.
Okay, so what I meant is if there is a restriction like award, like flowers, bouquet of flower can go only to A, or whatever. In this question, I see chocolates can be given to A or F. Such kind of restrictions are there. In such cases, only order matters, right? If these restrictions would not have been there, then order doesn't matter.
No, again, order will matter, because if you give a student, if there is no, for example, you have to distribute these order like among 3 students. These so you have 6 students. You have to divide these 3 awards to these 6 students, right? If it was suppose gold, let us forget about these chocolates and these. Let us take a simple case. We'll consider gold, bronze, and silver. Okay, that is also an award. In some event, it will be. So suppose you, me, and some other person, your friend.
Yeah.
In this case, if I get gold, you get silver, and your friend gets bronze. This is one case, right? But if you get gold, I get silver, and your friend gets bronze. This is separate case, right? And
no, but
order,
suppose the question is, suppose the question is how many ways the art can be distributed.
I'm doing
right?
that only. Yeah.
Okay. Well, in that we are just counting the number, right? Who gets what? We are not counting. We're counting.
No, we have to count who gets what, because in this case, it really matters who gets what. For example, if we had to choose, suppose I have to choose, suppose you, like I'll take you and your friend for out, we're just a group of friends. I'll take 2 friends out for dinner. Okay. I'll just take them. There is no order, like there is no ordering. One is like, if I take 2 friends, it's same. I am just taking those 2. There is no ordering, right? But now suppose I say I am taking 2 friends. One I am going to make captain of the team, another I am going to make vice captain, right? In this order
Then there
matters.
is order.
Then
So-
there is order, right?
Okay. So if so how I see that is, if same thing is being distributed, then order doesn't matter. If the
See,
things
basically how
are
you
different,
approach it is if you only have to select, you
Yeah.
don't have to worry about anything else. You just have to choose. Nothing else is your concern. Go for combinations. But if after selecting there is some sense of order, or you have to arrange, then you have to go for permutations. So basically what it boils down is to this. Like, this is a fact that most of the students, most of me, including myself, I wasn't able to clearly distinguish about these two. So what combination it basically is, combination is just selection or choosing, right? It is a 1-step process. You just choose. You don't do anything else. You just choose. Now, how do you link permutation to combination? Because they sometimes they might seem two entirely separate concepts, but in reality they are quite linked. Permutation, like now I just mentioned, combination is a 1-step process. You just choose. You don't do anything else. Permutation is a 2-step process. The first step being first you choose, okay, then you arrange.
Okay.
So basically in permutations, first we will have combinations and then arrangement. And because of that, you have that formula, NPR is equal to NCR into NPR is equal to NCR into R factorial, right? In that, NCR means first we are choosing, R factorial means we are arranging.
Yeah.
Okay. Thanks for explanation.
Yeah.
Got it now. Thank you.
So whenever you have like you have to deal with permutations, don't think of it something entirely different. It is a 2-step process. First you will choose, then you will arrange. On the other hand, combination is a 1-step process. You just choose, nothing else. Okay.
Yeah. Thank you.
Okay, I've got 16 responses. Let me see these responses. Okay, 18. 18, 12, 18, 4, 108, 120, 256. I've got a range of answers. So let's move to the solution. So now let's break down the question the way it has been given. First, we have to give chocolates, right? There are 3 gifts we have to give. The chocolates will be the first one. Okay, let's deal with the first chocolates. Chocolates can be given in 2 ways, like it has been mentioned in the question. It can either be given to A or to F. So we can give chocolates in 2 ways. Fine. Now we'll move to the other gift, that is toys. It can again be given in only 2 ways, right? Because it has been mentioned that it can be given either to A or C or F, right? Now, why only 2? Why not 3? Because we have already given from A or F, we have given 1 chocolate, right? Or either A or F, we have given one of those, we have given the chocolates, right? So 1 will be eliminated. As for example, if we have given C the chocolates, so C cannot receive the toys as well because each student gets only 1 gift. Because of that, we will be left with A or F. So again, we have 2 ways to give these toys.
If A
Okay,
is
so
given chocolate,
yeah.
If A is given chocolate, he won't be getting toys.
He won't be getting toys, exactly. That's what. So only then what 2 ways we will be left with? Either we will give toys to C or F, right? Okay, now we have total 6 students. Okay, out of those the restriction was on the first 2, right? Now we have given 2 students these, right? 1 student we have given chocolate, another student we have given some toys. Now we are left with 4 students, right? And there is no restriction on these 4. So we can give flower bouquet to any one of these 4. So we have basically 4 ways of doing that, right?
Sir,
So yes.
are we not considering the condition like, if A take chocolates, F can take only toy?
Yes.
And
no, he cannot take only choice. It's not saying F can or, since there is or, right?
Yeah, A or B or C.
Or
Okay,
there is
sir.
or.
Is there any mention about the flowers the children have provided?
No. There was no
what
mention
about
about.
C? He can take only toy, right?
Sorry?
C can take only toy, right?
Either only toy, it can be. He can be given toy. He can take another things as well. He can take a flower bouquet. For example, let us say if we give chocolates to A, okay? Now we give toys to F. C can be among those people who receive the flower bouquet, right?
Okay.
Because we have 6 students. We have given A chocolates, B for F we have given the toys. So C is there among the other students. 4 are left, right?
Yeah.
So basically, this is what it is. There is no restriction of gifting those bouquets to any students. But on chocolates and toys, we have some restrictions there.
Okay.
We have some cases that we have to consider. So then, total number of ways in which these awards can be given is basically first one can be given in 2 ways, and second in 2 ways, and third in 4 ways. So it will be 2 cross 2 cross 4, that is 16, right? Any doubts in this question?
Can we start with giving toys first?
So that is not the concern here. We can start with giving the toys first, but our only
Then
concern
also we'll
here.
get the same answer.
We'll get the same answer, right? Answer we will get the same number of ways. We will get same, but those ways might be different depending on whom we give what, right? We will get 16 ways. There will be 16 ways, but whom we give what, that may or may not vary depending on the way we give it. Okay, for example, if I say I will give toys first, I give F toys, right? Okay, then it's done. But if I say I will give chocolates first, I give A chocolates, and in the second case I give F these toys. Again, our F is getting these toys, right? First or second. So it is basically, these are the distinct arrangements that we get. But right now we are not concerned about the arrangements. For the arrangements, we were concerned when we had like in that EMQ, we were concerned with that. Right now, what we are concerned is the number of ways these can be given. That is clear from this. Okay.
So I have one very silly doubt, right? So
No, there is no doubt that is silly.
When do we use multiplication and when do we use addition?
Yeah. Basically, like one thing I'll tell you about these permutation and combination. Can you please somebody, Micah? So one thing about permutation and combination is there is one thing that is really interesting about this topic. The way you think or like the way you formulate these questions in the mind is the way you write. The way you write. Okay. If I'm saying, okay, the first student will get has 2 ways, and the second student has 2 ways, and the third student has 4. The third gift has 4 ways. I am basically using and, right?
Yeah.
So whenever you're dealing with these and situations, you are going for multiplication. Now, if I'm dealing with or, then we will go for addition. Okay.
Okay.
If I'm saying I can either take first road or the second road or the third road, then I will say, okay, I can take 1 + 1 + 1, 3 roads, right?
Yeah.
That's basically or and. Yes.
Sir, the number of ways to give twice 2. I could not be able to understand this.
Okay, I will say, suppose like this is given in the question that either A, we have number of ways to give chocolates. We can give chocolates to only A or F. Okay, this much is clear. Suppose we give chocolates to A. Okay. Now, going to the next case, number of ways to give toys. Now it will be 2, not 4, 3, because we have been given toys can be given to either A, C, or F, right? But in the first case, we just considered like I gave A the chocolates. Now I cannot give the same student again. Only C and F will be left. So I have again 2 ways only. Okay.
Yeah.
Okay, so we'll just proceed to the next question now.
Yeah. Sir, I have a doubt.
Okay.
Sir,
for others, just a moment. For others, they can solve this. Sorry.
Can I solve this using the permutation formula?
What?
That is combination
question
formula,
of giving 3 distinct awards to students.
You can like you have to give 2p2, 2p2, and 4p2. 4p4. That will be basically 2 into 2 into 4 again, right?
2p2, 2p2, and 2p4.
What is 2p2?
Sir, 2p2. Sir, and sir,
that is 2.
And that is 2.
So from a group of 2 students, 2 awards will be given.
So first you will choose 2 students. Let me break it down in terms of combination that will boil down to permutation. From A or B, you will choose 1 student, 2C1, right? You will choose 1. And how many ways can you give those? In 2 factorial. So that will basically boil down to 2p, right? 2p1. You have to give 1 student. From the 2A or F, you will give 1, right?
Yes, sir. 2p1. Yes, sir. 2p1.
So that way you can proceed with this question. Sorry?
Sir, in the twice section, it will be again 2p1.
Yeah, it will be again 2p1.
Because to one of the student we have given a chocolate. That is why.
Yeah, we have given. Yeah, basically what we have done is one of the students from either A or F, we have given them the chocolates. So we cannot give them again this like another gift because it has been clearly mentioned in the question. We can only gift them 1, right?
Yeah. Okay.
So we will choose 1 student for that. So it will be 4p1. For the second case, it will be again 2p1, right? Because we have 2. From 2 we have to give into 1, 2p1. And for the third, we will again do 4p1. So that will boil down to this 2 into 2 into 4.
Sir, what if I give twice first? Then I will have 3p1.
No, again you will have 2p1. Suppose you give twice first, okay?
Yes, sir.
Suppose you give twice to A.
Okay, sir.
You did in that case. Now we can
Then
give
chocolate can be
chocolates
given to only one person.
one person in that case, right? F.
Okay,
Then
sir.
also one.
Sorry? Or
Then
I
also one.
like if I give, suppose I gave in the second case, you are saying
Toy to
about toys
C.
first. I give toys to C. I give to C. Now I have again left with A or F.
Then we have two choices.
So basically, that's what makes it. It's a
Yeah,
permutation
then it makes
question,
4.
because ordering in this question is mattering. The way we give these, right?
Awards.
Awards.
So the calculations may
Okay.
change if we give the twice first.
Hello?
So I'm saying the calculations may change if we give the twice first. May the result will be same, but the calculations will be somewhat different.
A little result we will get the same, right?
Okay.
Okay. So have you done the next question?
No, sir.
Okay. Okay. Sorry, but.
Hello.
We don't know whether order matters or not.
Okay. Should we discuss the solution of this question now? Okay. Let's move ahead with the solution. We'll see the responses first. 1457, 1457, 1467, 1467. So most of this is 1457 and 1468. These are the routes. 1457 is what we get in majority, and that is the right answer for this question. Okay, now let's see how 1457 is the correct solution for this. So we have been given that there is a card game and there are 5 seniors and 4 juniors on a round table. Okay, So we have 5 seniors, 4 juniors. So total there are 9 people. Okay. The sitting arrangement, again, it will be simultaneous, right? And it will be without replacement, as one person can only take one position. He cannot sit on the first one seat and then get up on the other seat on the other seat, right? That it will be without replacement in that sense. Okay. So the first 4 options have been dealt with, and from that we get events will occur simultaneously. Therefore, option 1 is correct, and there will not be a replacement. So option 4 is again correct. Now moving on to 5, 6, 7, 8. Okay, now let us suppose that the seniors are denoted by these S1, S2, S3, and up to S5, and juniors SJ1, J2 up to J4. Okay, so then we can have one sitting arrangement like this, right? S1, S3, S4, S2. These are the like arrangements on the table that they will sit according to, but it will not be same as if junior one sits. For suppose we are 3 people, I stand there are 2 people from you, and one is like I am in the middle of you two, but it is not same as if I am at the end of you two, right? 2 people. So this making sense, following the same logic, we can see that order here is basically mattering, right? Because in different orders, if we sit differently, we will get different seating arrangements, right? So the order will matter, and therefore option 5 is correct. And when option 5 is correct, we are dealing with permutations, right? Whenever order matters, we are dealing with permutations. So therefore option 7 will also be correct. You clear? This question is clear? Any doubts?
No, sir. Sir, do we also have the concept of circular combinations?
Yeah, that we will see. Basically, we'll see in the following questions. We'll have now questions. These were EMQ type questions. We'll have now question subjective that you have to answer, and you will see what concepts you need to apply. Okay.
Okay, sir.
Okay, so moving ahead. Take your time to solve this question. This is for permutation and combinations. Don't like think too much. Am I going to use this formula? Am I going to use that formula? Don't like mug up too much on the formulas. See what you are going to do. Like apply it in practicality. If I have to seat 4 seniors and 4 juniors, how can I do that? What will be the ordering? Is there going to be ordering? Are the seating arrangements different and all that? Because permutation and combination, it's basically very practical, this topic. So
Yes,
take
sir.
your time to solve this.
Yeah. 5 factorial into 4 factorial. $2,880. $2,880.
Hello, sir.
Yes, hello.
Sir, I don't know from where all others are responding. The graph you show after the
Okay, basically there is this website you have to go on Peer Deck, join Peer Deck. Okay, there you will have the option to join as a student, and you can see that there is this code QLNWGX on the top right corner of the screen. Okay, so
Yes,
you have
sir.
to enter it there, and you will be able to see as well as respond. Mark your response there.
Okay, sir. Peer Deck.
Peer Deck, yes.
Thank you.
Okay, let's see the responses. Two people have got 2880, 8640, 144, 6040. Okay, so those who have got the answer as 2880, like, are they comfortable in explaining why they got 2880?
Yes, sir.
Okay, so why did you get 2880 answer?
Sir, we arrange in a circular round where 4 juniors to be seated together.
Hmm.
They are taken as one entity.
Exactly.
And 5 seniors are other. Total, it becomes 6 entities. And when we go for a round table, it minus 1 factorial. That is 5 factorial into that 4 juniors again to be arranged among themselves
in 4 factorial ways. Yes, exactly. That is the solution to this question. Let me get there. Sorry?
So could you please explain again? I did not get it.
I will do it. So how many seniors do we have? We have 5 seniors and we have 4 juniors. Okay. Now it has been asked in the question that the 4 juniors will always be seated together, like next to each other. Can we we'll consider them as one entity? Okay. We'll consider them as one. Okay.
Yes.
So basically, now how many items do we have? How many people do we have? If we are considering those 4 juniors as one, 6, 5 seniors, and this one entity of juniors, we have 6, right?
Okay. Yes. Okay.
So we have 6. So let me share my screen for this Just a moment.
It's okay, sir.
Can you see my screen?
Yeah.
Not this one right now. Can you see it?
Yes, yes.
Okay, so let me get here. Suppose these were our. This is the table we have. Sorry, my drawing is terrible. Suppose this is our table. We have like this: senior 1, senior 2, senior 3, senior 4, senior 5. Okay. What we do is we take these. Suppose these are the 5 juniors. We consider them as one entity: J1, J2, J3, J4. Okay, because they will always be seated next to each other. They will be like this wherever we put them, right? Even if we move them to from here to here, they will be like this only: J1, J2, J3, J4, right?
Yeah.
So it is safe to assume that we can consider them as one entity. Okay.
Okay.
Now we have this circular permutation. Suppose for the sake of better explanation, let me just define this by J. What J internally is, it's J1, J2, J3, and J4, right? So
Yeah.
how many, and this is circular permutation basically, right?
Hmm.
So how many, what is the formula for there? And how many objects do we have? We have 6 objects, 1, 6, right? So
Yeah.
it will be n minus 1 factorial, right? So it will be 5 factorial. Okay, this is clear. This is for this whole arrangement. We have 5 factorial. Now, these J's, juniors, they can be seated in how many ways internally? They can be J1, J2, J4, J3. So basically, they will be seated in 4 factorial ways, right?
Yeah.
So we'll
Right.
multiply this by 4 factorial. So that will be a solution to this question. Okay.
So why do we do n minus 1 for circular?
So basically, why we do n minus 1 in circular is this whole concept. There is a whole concept behind it. Let me just explain it quickly. So suppose we have this. Suppose we have 4 people: A, B, C, C, D. Okay. Now we have another combination like this. We have like again we have A, B, C, D. Again we have like let me consider 3. A, B, C, D. This will be A, B, C, D. Now this is not linear, like a linear combination in the linear. We are not arranging them linearly like we would. Or, so what we will do is basically this will what this will represent to, if we are starting from this, it will be like this. If we are going like this, it is A, B, C, D, right? This will be D, A, B, C. And this will be C, D, A, B, right? If we consider them in the linear fashion. Now, suppose I cut this table here. This is what I will get if I cut this table here, right? But I know this A, B, C, D, this D, A, C, D, A, B, C, this C, D, A, B. These are all same, right?
All are same.
All are same. Suppose this is U. You're on your left, you can see you're always having D and B, and right opposite to you it's always C. Even if you go there, opposite to you is C, B is on this side and D is on this side. Again, opposite to you is C, B is on this side and D is on this side, right? So for example, now if we have 4, we'll have 4. Another case will be where A will be here again, A, B, C, D, right? So these 4 cases basically they refer to one case only, right? These are equivalent to one case. So what we divide is by n, right? We had 4 people, we divide it by n only, right? What were the total arrangements? Those were n factorial. How many of these correspond to all the same case? That is n. In 4, it was 4 were corresponding to the same arrangement, right? So what can n factorial be written as? N into n minus 1 factorial over n, and n go. So we get from this n minus 1 factorial. Okay.
Got it, sir. Thank you very much.
Okay. Okay. So screen share. I'll stop sharing from here and I'll go to the share. This one. Okay, and now coming to this question, this is clear now why it is 5 factorial into 4 factorial.
Yes, now clear.
Okay, now let's move ahead to the last question for today. This is basically you just have to manipulate NP3 and N+1 P2. Okay. Okay, Harshit is asking how to join Google Discourse. So I think the support team does that on their own, Discourse. So you will be, while you will be given the link for that, or they radio on their own about that. Okay, so we'll now discuss the solution for this question. Anyone still solving? I can wait.
Three.
Three, okay? Okay. Okay. So let's get to the solution. Oh, sorry. So it's basically 3. Okay. It was more of a maths solution. It was more of maths 1 practice than stats 1, right? You just needed to know that formula and substitute it there. Then it was just solving that quadratic equation, and you'll get n as 3 and n as half. So since it has been given that n is a natural number, which eliminates n equals half. So what we are left with is n is equal to 3. So which implies n equals 3 is our solution for this question. Any doubts?
No, sir.
Okay, so this was pretty simple, straightforward question.
Yes.
So that will be all for today.
Thank you, sir.
Thank you, everyone.
Okay, thank you.
Thank you, sir.
And,
Thank you very much.
Sorry,
yeah,
if you don't
yeah.
mind, I have a one question. If you can help me with that.
Okay.
It's in week 6 activity question.
Oh, so there is activity. So
Yeah.
basically, I do not have access. There is some upgrading going on with the portal. Because of that, I have lost access to the post. But what you can do is for these like this type of questions, those questions that you have from practice assignments or activity questions or any general doubts, we have 2 sessions daily for stats 1. One is from 11 to 12 in the morning. Another one is from 3 to 4 in the evening. Okay, you can join those sessions and you can ask any question that you want, be it from week 1 or be it from week 12.
Sure.
Okay.
Good. Thank you.
That
Yes, sir.
there are 2 sessions. Those are for like to take care of some people might not be able to join in the morning and others might not be able to join in the evening. So to account for all those, we have 2 sessions daily. Okay.
So how can we get the link of those sessions?
Those sections you will have the link in Google, this calendar. What we are doing, we have 2 sessions. One is from 11 a.m. to 12. So in that session, what we are doing is we are regularly solving questions like this. Solve with us this session. We are regularly solving questions like these, questions from previous quizzes, mocks, or some questions that we take from some external sources. We are regularly solving questions, and there are a lot of people that are joining with us.
Thank you.
You'll have the link for that in your calendar. If you're not able to access those links, you can write to the support for that. Okay.
Okay, sir.
So I'll end the session now.
Okay, sir.
Okay. Goodbye, everyone.
Goodbye, sir.
Good night, sir. Bye-bye.
You're welcome.
Where are you from?
Good night, sir.
Good
Okay.
night.